Okay, so number 3 is finding the volume and surface area of a hexagonal prism. I gave you some hints yesterday on the video, so I'm going to continue from there. We break up the hexagon into 6 equal triangles. We find the angles. A whole circle would be 360. So since there's 6 triangles sharing that 360, we know that the top angle is 60. We split that in half when we draw the height of the triangle. That makes it a 30, 60, 90 triangle. Now, I used special right triangles to find the height here. If the short leg is 2, then the long leg will be 2 root 3. That's what I need to find the area of the triangle. So the area of the triangle will be 1/2 the base, which is 4, times the height, which is 2 root 3. So we get the area of the triangle is 4 root 3. Now the area of the hexagon is there's 6 triangles in the hexagon, so it's going to be 6 times that. So that's going to be 24 root 3 is the area of the hexagon. So that is the base of our prism. So to find the volume, big B stands for the area of the base times the height of the prism. So in this example, the volume of the hexagon is going to be 24 root 3, which is the area of the base, times the height, which is 7. So you can simplify that, work that out, and it's going to be, let's see here. Well, I don't have a calculator with me, so you can do it yourself. This will be cubic inches. Okay, so when you multiply that out, you get 291 cubic inches. So what's next? We need to calculate the surface area. So we need to make some room to do that. Do a little erasing here. So surface area is the total area of all the sides of the prism. So when we think about what we have going on here, we've got 2 hexagons and we've got 6 sides, right? So 6 rectangles to find the area of. And then we add all of those up. What does this say? It's supposed to say rectangles. Okay. Oh man, it just erased the area of the hexagon. Oh my goodness. Okay, the area of the hexagon again was 24 root 3, I think. You can yell at your computer right now if I'm wrong. I can't hear you, but it'll be satisfying for you to yell at me. Okay, and then we have the area of one of the rectangles. The rectangle is like right here, right? So that's like a 4 by 7 rectangle. So that's 28 square inches. And the area of the hexagon is 24 root 3 square inches. So the total area would be 24 root 3 plus 6 times 28. So the total surface area is 209.6 square inches. Moving on to your next homework problem. Carter wonders, what if the bases are circular? Discuss with your team. Oh, you don't have a team? We're in quarantine. So sad. I'm sorry, guys. How to calculate its surface area and volume if the radius of the base is 5 units and the height of the cylinder is 8 units. Alright, well let's start with volume. Volume will be the area of its base times the height. Its base is a circle, so that's pi r squared times the height. And this formula could be used for any cylinder. So the volume will be pi times the radius squared times the height. And that's going to be 25 times 8, which is 200 pi. If we leave it in terms of pi, and that's going to be cubic units. And then the surface area, we have two circles, the top and the bottom. So we have two circles, and okay, now the sides of a cylinder. Okay, have you ever taken the soup label off a can of soup? If we take the label off, so let's say we cut the soup label on the can and we open it up and we stretch it out on the counter, we have a rectangle. And that rectangle, since this is 5 and this is 8, that's basically going to be the circumference of the circle will be the length, and then the width of the circle is going to be what the height was. So the circumference of a circle, if you remember, is 2 pi r. So this will be 2 pi times 5. Okay, so we've got two circles and we've got the sides, whatever, side of the cylinder. It's a rectangle. And I'm running out of space. Let me do some erasing here. So again, with surface area, you want to show your work, be organized about your work, don't do calculations in your head. You want to map it out for yourself because there's a lot to keep track of here. So we've got the two circles, and we're going to find the area of each. So the area of one of the circles is pi r squared, which is pi times 5 squared, which is 25 pi. And we have two of those, so that's going to be 50 pi for the circles, the top and the bottom. So that's this area plus this area down here. And then the sides is 8 times 2 pi r. So that's going to be 8 times 10 pi, or 80 pi. So the total surface area is going to be 80 pi plus 50 pi, which is 130 pi. If we use a calculator, we just put in pi, 3.14 for pi, and multiply it out. And we get our surface area. So this would be square units, and that's that. Okay, Hernando needs to replace the hot water tank at his house. Poor Hernando. That's so sad. He estimates that his family needs a tank that can hold at least 75 gallons of water, but the tank must fit in a small closet. His local hot water tank supplier has a cylindrical model that has a diameter of 2 feet and a height of 3 feet. If 1 gallon of water is approximately 0.1337 cubic feet, determine if the supplier's tank will provide enough water. We need it to be 75 gallons of water. So let's find the volume of the tank. By the way, Hernando, you might want to check into getting a flash water heater. They're not cylindrical, but they're more efficient, fuel efficient, energy efficient. Okay, where am I? Sidetracked. Let's find the volume. The volume will be pi times the radius squared times the height. Okay, now be careful here. Remember, the diameter is 2 feet, so the radius is 1 foot. So that just simplifies to 3 pi is the volume. Now, since this is a real life problem, we want to multiply 3 times 3 pi, 3 times pi. And we get 9.42 cubic feet. And we need 75 gallons, so 75 times 0.1337 will tell us how many cubic feet we need. So 75 times 0.1337 is 10.03. 10.03 cubic feet. This one only holds 9.42 cubic feet, so it's not going to be enough water. Well, it's close, so they're going to have to decide.